Hello everyone. Today we're gonna go through the process of solving a non-homogeneous differential equation. During the process, we will answer multiple questions as to what is a homogeneous differential equation, what is a particular, how a particular solution is written, and what is the relationship between an homogeneous differential solution and a particular solution, as to if an homogeneous solution has solutions that appear in the general solution, what do we do about it? And finally, how a general solution is written. So 4 questions that we will answer during the process. So let's get started. What is the process to solve a non-homogeneous differential equation, which is also called the method of undetermined coefficient? So let's get started. First of all, non-homogeneous differential equation is under this form: ay second plus ay prime plus cy equals gt. And for non-homogeneous differential equation, gt is not equal to 0. And to answer the question as to what a homogeneous differential equation is, it's this form exactly, where ay second plus by prime plus cy equals gt, but in this case gt will be equal to 0. So when gt equals to 0, the differential equation is considered homogeneous. So the step one is to write the differential equation, the non-homogeneous differential equation, as an auxiliary solution equation, where we have a r second plus br plus c equals 0. This will help us find the homogeneous solution to the equation. And the homogeneous solution to the equation is found depending on the roots that we find. The roots are r, and the homogeneous solution will be a combination of r and t. Examples of those solutions are here, whether we find 2 roots, r1 and r2, whether there's only one root to the quadratic equation that we just had, on only one double root, or if our 2 roots are complex roots. So those are the 3 general homogeneous solution that we can find for the auxiliary equation. Moving on, this to step 2. So step 2 is how to write or find the particular solution. The particular solution being ypt. Ypt is found based on guesses, and those guesses are directed or guidelined by gt that we had at the beginning, being that the differential equation is equal to gt is different to 0. And how ypt will be different whether gt is a polynomial, gt is an exponential equation, or if gt is a trigonometric solution, or any combination of those 3. So in order to find gt, there is basic formulas that we can use to find gt. But I'm sorry, ypt, the particular solution. The particular solution can be based on gt if gt is a polynomial, if gt is an exponential solution, or if gt is a trigonometric solution. And here you have the results, or the particular solution that we are able to write based on gt. Here for this solution, YPT, the particular solution, is based on a GT that is a combination of an exponential and a polynomial. Hence, after those two steps, we are able to find we were able to find the homogeneous and the particular solution. And this method is also called the method of undetermined coefficient because of the A's here, A1, A2, A3, or A0 here, that are coefficients that we are supposed to find during the process. And the third step is basically writing the general solution. The general solution being the addition of your homogeneous solution and the particular solution that you found in the process that we just described. And at the end, you are able to, at the end of the process, you are able to find your general solution, being, for example, your general solution will be under the form of C1 exponential R1t plus C2 exponential R2t plus any particular solution that we're able to write. For example, we can take the example of a polynomial. So C1, so I can repeat myself. C1 exponential R1t plus C2 exponential R2t plus this YPT, and if we admit that m equals to 1, YPT will be equal to AT, and that's how you find your general solution. To answer to the third question as to if the solution of a homogeneous solution appears in the homogeneous general solution, basically when there's a repetition of the homogeneous solution in the particular solution, the thing to do is to multiply the initial particular solution by t, so you can find a new particular solution that does not have any repetition. Repetition being that a repetition of the homogeneous solution. So this is a simple formula that you can use. So if there's a repetition, if the homogeneous solution is repeated, you're gonna have your YP2t, which is gonna be your new particular solution, equal to t times YP1t. And you can continue doing this process up to YP3 or YP4, as long as there is a repetition of the homogeneous solution in the particular solution. And this is the end of the presentation, and I hope you enjoyed it. Thank you.